All right, so now let's look at some applications of derivatives. We have seen one application so far, which was slope of tangent line. Now, derivatives has like many applications, and we will spend like one full chapter for applications of derivatives. But for now, let's look at one or few, applications for now, and then we will get into more details later, and we'll spend, like I said, one full chapter. So I can say some applications for derivatives. So one of them was slope of tangent line, which we have seen this before. Another application in physics, basically velocity and acceleration. So let x of t denote the position of a particle at time t position of a particle at time t. Then the average velocity for this particle between two, let's say, different times, let's say between t equals t1 and t equals t2, is defined as v average equals x of t2 minus x of t1 over t2 minus t1. So this is called average velocity between two certain times, or we can also write it as delta x over delta t. So this is the average velocity between two certain times. And the instantaneous velocity of this particle at, let's say, sometime, let's say t equals t1, is defined as follows. So v of t1 is equal to limit x of t2 minus x of t1 over t2 minus t1 as t2 approaches to t1, which is same as limit delta x over delta t as delta t approaches to 0. Okay, so because for average velocity, we need to have two times, t1 and t2. Now, if t2 approaches to t1, meaning that t2 gets closer and closer to t1, then the average velocity between t1 and t2 will be called instantaneous velocity at t1. So let's say, for example, you want to know the velocity of your car at 12 p.m. So one option is that you look at the average velocity between 12 p.m. and 12:05 p.m. But if you want to have a better estimation for the velocity exactly at 12 p.m., so instead of 12 and 12:05, you can consider the average velocity between 12 and 12:01. If you want to have a better estimation, you can consider the average velocity between 12 and 30 seconds after 12. even better estimation 12 and 1 second after 12. So if you consider the average velocity between 12 p.m. and 1 second after 12 p.m., then that's a good estimation for instantaneous velocity at 12 p.m. If you want to have even better estimation, you can consider between 12 p.m. and let's say 1 millisecond, 1 millisecond after 12 p.m. and so on. So this is the velocity of the particle at t equals t1. This is how we define it. So in other words, v of t is equal to x prime of t, or dx to dt. Okay, so this is for velocity. Similarly, the acceleration at t at time t is defined as, so a of t is defined as v prime of t, the derivative of velocity, which is dv to dt, or in other words, in terms of x of t, we can say a of t is the second derivative of x of t, or d squared x to dt squared. So this is how we can define velocity in terms, acceleration in terms of velocity is the first derivative. In terms of position function is the second derivative. So let's look at an example. Let's say a particle moves in one dimension or along the real line, along a straight line, with, let's say, x of t equals 2t squared plus 5t minus 5t plus 1. So part A, find an estimation for velocity at t equals t1, and t equals, let's say, 1 second. Part B, find the exact value of velocity at t equals 1 second. And part C, at which time the velocity becomes 0. So for part A, for estimation for velocity at t equals 1 second, so we said that instantaneous velocity at some point can be estimated by average velocity between that point and some time close to that point. So t equals 1 second is given. If I choose a time close to 1 second, such as, let's say, 1.1 second, for example, then I will have an estimation for velocity at 1 second. So average velocity between, let's say, t equals 1 second and t equals 1.1 second, let's say, provides an estimation for a v of t at t equals 1 second. So why did I say 1.1? It's just a number close to 1. You could say 1.01. In fact, if you choose 1.01 rather than 1.1, if you choose the average velocity between 1 second and 1.01 second, then that's even a better estimation, because 1.01 is even closer to 1 compared to 1.1. Or if, let's say, if you say 1.001, then it's even better estimation. But because the question just says find an estimation, doesn't say how exact the estimation should be. So any of these numbers are acceptable for the exam. I chose 1.1 second. So V average is equal to x of 1.1 minus x of 1 divided by 1.1 minus 1. So this is how much? This is 2 times 1.1 squared minus 5 times 1.1 plus 1 minus 2 times 1 squared minus 5 times 1 plus 1 divided by 1.1 minus 1. See, I'm not simplifying or writing in decimals yet, because I'm hoping that maybe I can simplify things even without calculator. Of course, I can use calculator to calculate these numbers and find the final answer. But even without calculator, I can cancel 1 with this minus 1 here. And then I'll be left with 2 times 1.1 squared minus 1 squared minus 5 times 1.1 minus 1 divided by 1.1 minus 1. So then I'll get 2 times, I can take 1.1 minus 1 out. And then from the first factor, 1.1 plus 1 will be left. From the second factor, so let me just take 1.1 minus 1 out. And then from first factor, 2 times this will be left. From second factor, minus 5 will be left. And then divided by 1.1 minus 1. This cancels with this. Then the answer is 2 times 2.1 minus 5, which is 4.2 minus 5, which is minus 0.8. Let's say meter per second. So this is the average velocity between t equals 1 second and t equals 1.1 second, which is estimation for instantaneous velocity at t equals 1 second. Okay. Now for part B, we have to find the exact value of velocity at t equals 1 second. So let's do that. For part B, the exact value, so V of 1 is equal to x prime of 1. Velocity at t equals 1 is same as derivative of x at t equals 1. Stop share and share again. The screen is freezed. Yeah, velocity at 1 is the derivative of x at t equals 1. And what is that going to be? Limit x of 1 plus h minus x of 1 divided by h as h approaches to 0. And then this is limit, what is x of 1 plus h? So we have x of t. I have to replace t with 1 plus h. I'm going to get 2 times 1 plus h squared minus 5 times 1 plus h plus 1 minus 2 times 1 squared minus 5 times 1 plus 1 divided by h approaches to 0. And then again, we can simplify this limit 2 times 1 plus h squared plus 2h minus 5h plus 1 minus 2 plus 5 minus 1 divided by h. So 1 and minus 1 here, they cancel. And then I'll be left with limit 2 plus 2h squared plus 4h minus 5 minus 5h minus 2 plus 5 divided by h approaches to 0. And then 2 and minus 2, they cancel. And 5 and minus 5, they cancel. So I'll be left with limit h times 2h. And then we have 4h minus 5h, that's minus h, but h's I'm taking out, so minus 1 divided by h approaches to 0, right? So 4h minus 5h is minus h, but I'm taking h out. So what will be left? Minus 1 will be left. Now h cancels with h, so limit 2h minus 1 as h approaches to 0 is minus 1. So the answer is minus 1. That's the exact value. So v of 1 equals minus 1, right? Which is consistent with what we got in part A. We got that minus 0.8 is an estimation for the velocity at t equals 1. In part B, we can see that velocity at t equals 1 is minus 1. So it makes sense that, minus 0.8 is an estimation for this value. Now part C, at which time the velocity becomes 0. So v of t, we want v of t equals 0. And we want to find t. So what is v of t? Let's first find v of t. V of t means limit x of t plus h minus x of t divided by h. H approaches to 0. And then this is limit. Now what is x of t plus h? Again, we have to replace the formula for t, 2t squared minus 5t. So 2 times t plus h squared minus 5 times t plus h plus 1 minus 2t squared minus 5t plus 1 divided by h. H approaches to 0. And then this is limit 2t squared. So 2 times t squared plus t squared plus 2th plus h squared, and then minus 5t minus 5h plus 1 minus 2t squared plus 5t minus 1 divided by h. H approaches to 0. And then what will be the answer here? So this will be limit, so 2t squared and minus 2t squared, they cancel. So I'm going to be left with 4th plus 2h squared minus 5h, because minus 5t plus 5t, they cancel. 1 and minus 1, they cancel. So that's it, 4th plus 2h squared minus 5h divided by h. H approaches to 0. And then this is limit h times 4t plus 2h minus 5 divided by h h approaches to 0, h cancels. Now the answer, as h approaches to 0, 2h will go to 0. The answer will be 4t minus 5. So we concluded that v of t is equal to 4t minus 5. Now remember, we wanted to solve for v of t equals 0, and we want to find t. So v of t equals 0. That means 4t minus 5 equals 0. And that gives t equals 5 over 4. So this is the time where velocity becomes 0. Okay, so now let's look at the equation of a particle in a free fall. So equation of motion for free fall. So let's say we just throw an object at some height, or we drop it, throw it or drop it. Let's say we drop it. This is height h, and let's say drop an object. Let's say this is the floor. So when you drop an object from height h, so the gravitational force will be applied to the object. So so suppose that we drop or throw. We could also throw it, let's say, upward. That's also possible, right? Either drop or throw. You could also throw it downward. This is throwing upward. You could also throw it downward. Anything possible. So suppose that we drop or throw an object from height h. Then by Newton's law, what does Newton's law say? It says F is equal to ma. And what is F? The gravitational force is minus mg, right? Gravitational force is minus because it's downward. So downward means minus. So minus mg equals ma. And that gives the acceleration. Acceleration equals minus g, which is almost equal to 9.8 meter per second square. Okay, so the acceleration, whether you drop an object or throw it upward or downward, in any case, the acceleration will be constant according to Newton's law, because gravitational force must be ma, and gravitational force is minus mg. So minus mg equals ma. That means a equals minus g, which is a constant, almost 9.8 meter per second square. So what can I say about the equation of v and equation of, so equation of a, we have it. Equation of a, we have is just a constant, minus g. What about equation of v? So what do we know? So we know that a of t should be derivative of v respect to t. So derivative of which function will be a constant function? So we will see that derivative of, let's say, cx plus d is c. Okay, so after this topic, I'll tell you about the derivative rules. We'll see that derivative of a function like cx plus d is c. So now here you want, the derivative is c, which is minus g here. So what should be the original function? Let me write it here. we see that cx plus d derivative is c. Now here, dv to dt is equal to minus g. So what is v? So v of t must be of the form t equals minus gt plus, let's say, some v0. Or let's say I can call it plus d. Is this clear? See, instead of x, here we have t. So please note here, I always say in all courses, also differential equation course, for example, or any other course. Sometimes in mathematics, normally the independent variable is denoted with x. But in physics, normally the independent variable is denoted with t. Okay, so here when I say cx plus d derivative is c, that means if the independent variable is x, then derivative respect to x is c. But here t has the role of x. So derivative of v respect to t is minus g. So my c value here is minus g. And instead of x, I'm using t here because in physics, we assume that the independent variable is time, which we denote with t. So if derivative is c, which is minus g here, what is the original function? If derivative, here we can use this formula. See, if the derivative is c, the original function must be cx plus d. But here, instead of x, I have t, so ct plus d, and my c is minus g. So minus gt plus d. Now, what is d? So v of 0, let's look at v at 0. So the initial velocity. I want to find d, okay? So let's look at the initial velocity, meaning velocity at t equals 0. So at t equals 0, v of 0 is equal to minus g times 0 plus d, which is d. And let's call this one v0, v0. So the v0, where v0 denotes the velocity at t equals 0, i.e. the initial velocity. So we have the initial velocity. So there you are. So we found d. So that means v of t is equal to minus gt plus v0. Similarly, we can find x of t. Similarly, v of t is equal to dx to dt, and this is minus gt plus v0. Again, we will see that, let's say, if you have a function of the form, let's say cx squared plus dx plus e, then the derivative of this function will be 2cx plus d. So here, instead of x, we have t first of all. We explained about this. And my 2c will be minus g, right? Because t will be replaced by x will be replaced by t. Now the coefficient of t is minus g. So 2c will be minus g, which means c is minus g over 2. And d is, so the constant is v0, v0. So thus, the equation will be x of t will be ct squared plus dt plus e. Now, c is minus g, so minus g over 2t squared plus v0t plus e. Now, how can I find the e? Again, to find e, we can use x of 0. X of 0 will be how much? 0 plus 0 plus e, and this should be x0, which is the initial position, where x0 denotes the initial position. So that means x of t is equal to minus gt squared over 2 plus v0t plus x0. This is the equation of motion. Equation of motion. Equation of motion for free fall. Okay, so let's look at an example. Suppose that we drop, let's say part A, suppose that we drop an object from the height 20 meters above the ground, find the velocity of this object at the time that hits the ground. Okay, so here we have 20 meters here, x0 equals 20 meters, the initial position. And then we want to see when it hits the ground. So what is the equation? The equation of motion. So we just drop it. So v0 is 0, right? So we don't give any initial velocity to it, just drop it. So x of t will be equal to minus 1 over 2 gt squared plus v0t plus x0. Now v0 is 0, x0 is 20, so minus g over 2t squared plus 20. So let's, for simplicity, assume that, let's say g is almost 10 meter per second squared. So let's assume g is 10. Then this is minus 5 t squared, right? Because it's minus g over 2 t squared. And g is almost 10. So this is minus 5 t squared plus 20. Now we want to know what is the velocity at the time that hits the ground. So first, let's find the time that the object hits the ground. So the time of hitting the ground. How can I find it? I need to set x of t equals 0. So then I'll have minus 5t squared plus 20 equals 0. And that means that t squared equals 4. And therefore t equals 2, because t has to be, of course, positive. Second, right? So 2 seconds, at 2 seconds, it hits the ground. And what will be the velocity at this time? So we know that v of t is equal to dx to dt, derivative of t. And how much is this? This is going to be derivative of this function. So minus d to dt of minus 5t squared plus 20. So like I said, we said that we have a formula for cx squared plus dx plus e. Derivative, we will see that this is 2cx plus d. Okay? This one, I promised you that we will see this. So derivative of this function, 2cx plus t, instead of x, we have t here. So minus 10t, that's it, plus 20 derivative will be 0. All right, so my e value here is 20, my d value is 0, my c is minus 5. So 2 times minus 5 minus 10, instead of x I have t plus d, but d is 0. 20 is a constant, and we will see that derivative of constants are 0. Okay, so we will see these as derivative rules. We'll see this shortly, but please accept this for now. So this is minus 10t. So at t equals 2, which means the time of hitting the ground how much is the velocity? Velocity at the time 2 is minus 10 times 2, which is minus 20 meter per second. So this is the velocity of the object when it hits the ground. Okay, now part B of this question. So suppose that we throw, so part A we dropped and I showed you how to do it. But this is part B, suppose that we throw. Suppose that we throw this object upward with the velocity, the initial velocity, let's say 5 meters per second. And then find the maximum height of this object. And again, maximum height of this object and the velocity at the time that it hits the ground. Okay, so again, we have 20 meters here. This is the ground. This is 20 meters. So what is x of t, and v0 this time is 5 meters per second. So x of t is minus g over 2t squared plus v0t plus x0. So this is minus 5t squared plus 5t plus 20. Okay, and v of t is minus gt plus v0. So this is minus 10t plus 5. So now this is x of t, this is v of t. We had these equations before, we derived them before. Now we want to know at the maximum height. And so just imagine the object, you throw it upward from height of 20 meters. So it goes up a little bit. At some point it will stop and then comes down. So the time that it stops, that's the maximum height. So the time that it stops means the time that velocity becomes 0, right? So imagine the object goes up and the velocity becomes slower and slower. It stops at some point, then it comes down. So the time that it stops, so that is the time where it reaches the maximum height. So first, let's find the time that it stops. And then once we have the time, we can find x, because we know the equation of x of t. X of t means once you have the value of t, you can find the value of x. Okay, so at maximum height, let's write it this way. At maximum height, we have v of t equals 0. Velocity becomes 0 at maximum height. So what does that mean? That means minus 5t, minus 10t, minus 10t plus 5 equals 0. That gives t equals 5 over 10, or 1/2. 5 over 10 equals 1/2. So this is the time of maximum height. And how much is the position then? So the maximum height will be x of 1/2, right? So x of t, we have the equation at 1/2. That's going to be, so this is the, sorry, this one. This one is the equation at time t, at t equals 1/2. This will be minus 5 times 1/2 squared plus 5 times 1/2 plus 20. And then this will be how much? So minus 5 over 4 plus 5 over 2 plus 20. So this is 10 over 4 minus 5. This is 5 over 4 plus 20. And this is 85 over 4 meter. So this is the maximum height. And finally, we also want to find the velocity at the time that it hits the ground. So how much is the, first let's find the time when it hits the ground. So the time, lastly, the object will hit the ground if x of t equals 0. So that gives minus 5t squared plus 5t plus 20 equals 0. So I can take minus 5 out. T squared minus t minus 4 equals 0. And then how much will be t? So then t squared minus t minus 4 equals 0. And then t equals minus 1 plus minus root b squared, which is 1, plus 4 times 4 minus 4ac divided by 2. So minus 1 plus minus root 17 divided by 2. So then minus 1 we have to reject. So t equals minus 1 minus root 17 over 2 we have to reject. And therefore we'll have t equals minus 1 plus root 17 over 2. And therefore the velocity at this time, the velocity at this time will be v of minus 1 plus root 17 over 2. And that's going to be how much? So we have the equation for v of t here. V of t here, and we'll have the value of t. So minus 1 plus root 17 over 2. So that's going to be minus 10 times minus 1 plus root 17 over 2. And then plus plus 5 plus 5. And that's minus 5 times minus 1 plus root 17 plus 5. So that is 10 minus 5 root 17 meter per second. Okay, which is a negative number, of course, and negative numbers and number verifies that the velocity is downward. So that's why the answer will be negative. Okay. So another thing I want to say, another application basically, which is a generalization of the concept above. Basically, average and instantaneous rate of change. So this velocity is a rate of change of position is called velocity. So now average rate of change will be called average velocity, instantaneous rate of change, instantaneous velocity. So what I want to say is that the same concepts that we saw for physics, when we have x of t and then delta x over delta t, we call average velocity, dx to dt, or the derivative we call instantaneous velocity. So we can apply the same concepts in other areas other than physics. For example, it could be profit of a company. So let's say P of X could be a profit of company. Then instead of a velocity, then we don't have velocity in that case, but still we can talk about average rate of change of profit or instantaneous rate of change of profit, right? So this concept can be applied in other areas. So let y cos f of x be a function. Then the average rate of change of y respect to x between, let's say, two certain times, let's say between x equals x1 and x equals x2 is defined as delta y over delta x, which is f of x2 minus f of x1 divided by x2 minus x1. This is called the average rate of change of y respect to x between x1 and x2. So average rate of change is always defined between 2 points, x1 and x2. And similarly, instantaneous rate of change, of y respect to x, let's say at x equals x1, is defined as f prime of x1. So derivative at x1, another name for derivative at x1 is instantaneous rate of change of y or instantaneous rate of change of f of x at x equals x1. Okay, so this is a very important thing. Instantaneous, when they talk about rate of change in calculus, it's either average rate of change. Average rate of change is defined between two x values, and that has nothing to do with derivatives. It's just delta y over delta x, a concept that you learn in high school, right? So average rate of change is just a high school concept, nothing to do with derivatives, just simply delta y over delta x. Instantaneous rate of change, however, is another name for derivative of a function at x equals x1. So instantaneous rate of change of y respect to x at x equals x1 is defined as f prime of x1, which can be written as limit f of x2 minus f of x1 over x2 minus x1, x2 approaches to x1, or we can also write it as limit delta y over delta x as delta x approaches to 0. So let's look at an example. Let's say let y equals 3x cubed plus x. Find the average rate of change of y with respect to x between x equals 1 and x equals 4. So that's going to be delta y over delta x, which is going to be f of 4 minus f of 1 divided by 4 minus 1. F of 4 will be 3 times 4 cubed plus 4 minus f of 1 will be 3 times 1 cubed plus 1 divided by 4 minus 1. And then this is 3 times 4 cubed minus 1 cubed plus 4 minus 1 divided by 4 minus 1. How much is this? So this is 64 minus 1. 63. So 3 times 63 plus 3 divided by 3. So then I can say 3 times 63 plus 1 divided by 3. The answer is 64. So this is the average rate of change between x equals 1 and x equals 4. Let's say I can also add part B. Let's say find the instantaneous rate of change of y at, let's say, x equals 1. Instantaneous rate of change is another term for f prime of the number. So here we want to find f prime of 1. F prime of 1 is equal to limit. So this is instantaneous rate of change at x equals 1. So then this is limit f of 1 plus h minus f of 1 over h. H approaches to 0. And then this is limit f of 1 plus h. We have f of x here. So replace x with 1 plus h, 3 times 1 plus h cube plus x. So we have to replace x with 1 plus h minus f of 1. F of 1 is 4, right? F of 1 is 4 divided by h. H approaches to 0. And then this is limit 3 times 1 plus h cubed, 3h squared, 1 plus h minus 4 divided by h approaches to 0. So 3, so this will be 3 times 1 is 3, plus 1 is 4, 4 minus 4 is 0. So then I'll have limit and 3h cubed plus 9h squared and plus h divided by h approaches to 0. And then this is limit 3h cubed plus 9h squared, 10h divided by h approaches to 0. H, I can take it out, 3h squared, 9h, 10. And then the answer will be 10. Because h approaches to 0, so 3 times h squared and 9h, they both go to 0 as h approaches to 0, and then I'll be left with 10 as the final answer. So this is the instantaneous rate of change at x equals 1. All right, now we have a few minutes left, so let's start learning about some derivative rules. So differentiation or derivative rules that can help us to calculate derivatives without finding the limits. Because so far, to calculate derivative of a function, we had to find the limit, f of x plus h minus f of x over h, and calculating that limit could be lengthy in some cases. But with derivative rules, basically, so the goal is we can, bypass calculating the limit of f of x plus h minus f of x over h as h approaches 0 to calculate the derivative of a function. So the goal here basically is calculating a derivative of a function quickly without finding, without evaluating limit f of x plus h minus f of x where h approaches to 0. So of course, to prove the rules, we have to calculate the limit, right? But once we do it only once to prove the rule. Once we prove the rule, then you can just use it to calculate derivative of a function, unless the question asks you to prove the rule. In that case, again, of course, you have to use the limit definition. Or if the question says calculate the derivative using the limit definition, then again, you have to use the limit definition, which is this definition here. But other than that, you are allowed to use the rules that we are going to state right now. So the very first rule here, so first rule is that if y equals f of x equals c, a constant function, then the derivative y prime equals dy to dx is equal to 0, because f prime of x equals 0. So the derivative of a constant function is 0. So proof. So let's see how we can prove it. So f of x equals c, and we want to find f prime of x, right? So how can I find f prime of x? F prime of x by definition is limit f of x plus h minus f of x divided by h as h approaches to 0. Now, f of x is a constant function. So constant function means the output is always the same, no matter what the input is. So whether the input is x plus h or x or whatever, the output is always c. That's the meaning of a constant function. So the output is, so limit c minus c divided by h approaches to 0. And then this is limit 0 over h approaches to 0. So now tell me, Here we have h approaches to 0, so I will have a fraction of the form 0 over 0. So previously we have seen that if you have a 0 over 0, then the limit will be indeterminate, meaning that the answer could be potentially anything, and we have to simplify to find out what the answer is. So do you think this limit is indeterminate or no? The answer is this limit is not indeterminate, and the answer is 0. Why? So this is very tricky. Note, note in fraction above, we have a number of the form. See this number, look at this fraction. The numerator is exact 0 over limit 0. Yes, 0 over 0 is indeterminate, but when we say 0 over 0, we mean limit 0 over limit 0. We mean something close to 0 over something close to 0. That's the case that we had before when we studied limits. But here it's not limit 0 over limit 0. So numerator is exact 0. So 0 over limit 8, but denominator is limit 0 because denominator is not exactly 0. Denominator is h, and h approaches to 0, which means gets closer and closer to 0. So this fraction, if you want to get some idea about this fraction, so this is something of the form, let's say 0 over, for example, 0.1. So something like if you have 0 over 0.1, how much is 0 over 0.1? 0 over 0.1 is 0 because this is exact 0. 0 over any number is 0. Any number other than 0. 0 over any number other than 0 is 0. So 0 over 0.1 is 0. 0 over 0.01, for example, this is also 0. 0 over 0.00001, this is also 0, right? So denominator gets closer and closer to 0, but numerator is exactly 0. So exact 0 over any number is 0. Right? So in fraction above, we have a number of this form, which is equal to 0. Which is 0. In other words, this fraction is not indeterminate. The indeterminate form, that we had before was limit 0. If you have limit 0 over limit 0, then that's indeterminate, and the answer could be anything. Because, for example, let's say 0.1 over 0.1 or 0.01 over 0.01, right? So these are 1. Limit 0, limit 0, limit 0, limit 0, and the answer is 1. But the answer could be something else. For example, 0.00001 over 0.1. Then this is like 0.0001, right? So still very close to 0, right? So if you have something of this form, this is limit 0 over limit 0, the answer is very getting closer and closer to 0. So the limit will be 0. If you have a limit whose numbers are of this form, then the answer will be 0. If this number here gets closer and closer to 0, the answer will be 0. But if you have a limit where the numbers, when you replace x with the numbers getting closer and closer to 0, you get numbers of this form or this form, then the answer will be 1 and 1 and 1. And let's say if the outputs are all remaining 1, then the limit will be 1. So that's why we say indeterminate, because depending on the example and on the function, the answer could be 1, the answer could be 0, the answer could be infinity in some cases, it could be 10, for example, in some cases, could be negative number in some cases. So it depends on the function, depends on the example. But when you have exact 0 over limit 0, then no, it doesn't depend on the example or the function. Exact 0 over any number other than 0 is always 0. Okay, so I want you to notice this and be careful that normally we have limit 0 over limit 0, but in this case we have exact 0 over limit 0, and the answer was 0. So this one, f prime of x, we showed it's 0. Yeah, so for example, let's say f of x equals 5. Find f prime of x. So f prime of x will be 0, because by rule 1 above, derivative of a constant function is 0. Okay, so this is the first and simplest rule of derivative, that derivative of a constant function is 0. So in the next step, we have to look at derivative of polynomials. For example, derivative of a linear function or derivative of a quadratic function. Okay, so that's also simple, but we'll do that next time. Okay, guys, so next time we'll continue the derivative rules, and we'll see how we can use them to calculate derivative of any given function. Okay, guys, so thank you and see you next time.